So in section 2, we're going to take polynomials and we're going to begin by factoring them and finding zeros and doing a little bit of graphing. So our objectives, we're going to answer the question, what important information can we decipher from polynomials? So we're going to analyze the factored form of a polynomial and then write a polynomial function from its zeros. So we're going to work forwards and backwards. Same information. So for our vocabulary, the factor theorem describes the relationship between the linear factors of a polynomial and the zeros of the polynomial. It just shows that they're a one-to-one correlation. When there is a repeated linear factor, such as x plus 2, if you have two of them, it makes negative 2 a multiple 0. So if you have x plus 2, and you factor, your solution is x is negative 2, but since you have it twice, we call that a multiple. In particular, you can say that negative 2 is a zero of multiplicity, and so in the homework it'll ask you like, what are our zeros of multiplicity, and then it'll ask how many times. Is it 1 0? Is it 2 zeros? If the graph of a polynomial function has several turning points, the function can have a relative maximum and a relative minimum. So instead of having like a full maximum and minimum, if it turns, like if we have a turning point, let me just do like a quick sketch. Like if it does this kind of thing, this would be a relative maximum, this would be a relative minimum. Because even though it's not the highest and lowest point of the graph, it's relative to a certain space on the graph. Alright, so writing a polynomial in factored form. So we want to factor x cubed minus 2x squared minus 15x. What do you notice about the three terms? Well, there's an x in each one of them, so let's go ahead and factor out that x. So I get x squared minus 2x minus 15. Now, can we factor this? What are my multiples of negative 15 that add up to be negative 2? Well, 3 and 5 make 15, so I'm going to have x minus 5, x plus 3. So that's my factored form of this polynomial. And we can check by foiling to make sure that we got it right. Okay, why don't you go ahead and try this one, see if you can find the polynomial, factor it, and make sure you pause the video, don't be cheaters. Alright, when I take out the x out of everything, I get x times x squared minus x minus 12. So this is x times x minus 4, x plus 3. Oops, forgot the plus. Okay, so those are my factors of my polynomial. Okay, for finding zeros, when we're going to use the zero products property again, but when we go ahead and have it into its factors, just like we did in section, what was that, 5 or 6, we can take those factors and set each one of these equal to 0. So if I have x plus 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0, my solutions are x equals negative 2, positive 1, positive 3. So those are my three solutions. And then we can find points for x values that are between the zeros. So between negative 2 and 1, we have negative 1 and 0. And between 1 and 3, we have 2. So we want to go ahead and find those values for our polynomial and plug them in, and then determine their end behavior. So I'm going to go ahead and multiply this out so that it's easier to do. So I'm first going to multiply x plus 2 times x minus 1. So that's x squared minus x plus 2x. That's a plus x minus 2. And then I need to multiply that times x minus 3. If you didn't know how to multiply a binomial and a trinomial, you just multiply each one. It's very fascinating. Okay, so I have x cubed. Is that that's a plus x. So plus x squared minus 2x minus 3x squared minus 3x plus 6. combine my like terms. I have an x squared, negative 3x squared. So I have x cubed minus 2x squared minus 5x plus 6. So my zeros are x equals negative 2, 1, and 3. I'm going to go ahead and put this on, no, don't do that. I'm going to put this on a chalkboard so I have a little more space to write. Okay, so on my graph, I know that I'm going to cross negative 2, this is a point, 1 is a point, and 3 is a point. Now, in order to find what's happening at the other points, I need to plug in those values that we discussed, those in-between values. So we said negative 1, 0, and 2. I'm going to plug those in for my x's. So if I plug in 0, I get 0, 0, 0, 6. So I know 0, 6 is a point. Ooh, I kind of like that white. Alright, and then if I plug in negative 1, negative 1 cubed is negative 1, that's positive 1, negative 2, plus 5, plus 6, 11, 8, so negative 1, 8 is a point. I also need to plug in 2. Let me erase this one. Let's see. 2 cubed, 2 times 2 is 4, times 2 is 8, minus 8, so that becomes 0, minus 10 plus 6, so 2 is 4. Okay, and it's cubed, so it should change direction up to 3 times. It's going to do this thing. 1, 2, 3 directional changes. So there's our graph. Isn't it lovely? Alright, so if we are given the zeros, so our zeros are negative 2, 2, and 3, we're going to write a function from those. So if we know our zeros are these, what can we assume our factors are? Well, when we had x minus 2 as a factor, x equaled 2. So then our factors are going to be x plus 2, x minus 2, and x minus 3. Now we're going to go ahead and multiply these just like I did on the last slide. So we're going to use FOIL first. So first is x squared, outer is minus 2x, inner is plus 2x, and last is minus 4. These two cancel. Also, this one's nice. So I have x squared minus 4 times x minus 3. So since I have two factors again, I can just use FOIL a second time and do first, outer, inner, last. And I get x cubed minus 3x squared minus 4x plus 12. And that is a polynomial with the zeros negative 2, 2, and 3. Alright, so finding these zeros of multiplicity. So what are the zeros, and then how does the graph behave? So for these, in order to find zeros, what we have to do is we have to factor it first. So is there anything that x to the 4th, 2x cubed, and 8x squared have in common? Well, they all have x squared, so I'm going to take that out first. That gives me x squared minus 2x minus 8. Is this factorable? Let's see. Yes, it is. So I have f of x equals x squared times x minus 4 times x plus 2. That makes negative 8 when you multiply and negative 2 when you add together. So I can set each one equal to 0. So x squared equals 0, x minus 4 equals 0, and x plus 2 equals 0. The first one, take the square root. This square root of 0 is 0, but technically I have two zeros because I would have a positive and a negative 0. So this would be our multiplicity. X equals 4 and x equals negative 2. Since it's x to the 4th power, we should have 4 solutions. 1, 2, 3, 4. So 0 is a multiplicity of 2, and negative 2 and 4 are both multiplicity of 1. So they only have 1 0. And then finding relative max, relative min. What you do with these, you use your graphing calculator. You just put it into your y equals, and then you might have to zoom out in order to see what's happening. So you can change your window or you can zoom. You can also use the table feature. And then I like to use the max min feature. So if you go to second cal and go down to, which one is it? 3 is the minimum, 4 is the maximum. You can find your relative minimum, relative maximum. So if this has x to the 3rd power, we have a possible 3 changes of direction. So make sure you pay attention to what's happening with your curves and that you get everything included. And this is the last one. In order to find maximum value, and this one's a little tricky, but it says the design of a digital box camera maximizes the volume while keeping the sum of the dimensions at 6 inches. If the length must be 1.5 times the height, what should each dimension be? Okay, what do you know about volume? Volume is length times width times height. So imagine we just have some kind of box, and we know that our dimensions all add up to be 6. So the length must be 1.5 times the height. So if we say height is x, we know the length is 1.5 times x. What do we know about the width? Well, right now we don't really know anything about it other than our width has to be 6 minus whatever our height is times whatever our length is times whatever our width is. Our width is 6 minus those, right? Yes. So we can go ahead and multiply these. So width is 6 minus 1.5 x squared. And then we can plug in for length, height, and width. So our length is, so volume equals 1.5x times our width is 6 minus 1.5 x squared times our height is x. This looks like a lovely problem. Alright, so I'm going to go ahead and start by distributing this through. So 1.5 times 6 is 9 minus 1.5 squared is 2.25x cubed, and then I need to multiply these times x. So I get negative 2.25 x to the 4th plus 9x squared. Now in order to find my possible solutions, I'm just going to go ahead and graph it and put it into my y equals and find my zeros. So go ahead and do that. So when I graphed it, I got this kind of weird shapey thing. I know 0 can't be a solution. I know a negative number can't be a solution. So my only solution was this one here, and I got x equals 2, because we can't have negative height unless it's like falling into the earth, which I'm pretty sure it's not being cut out of the earth since it's a digital camera box. Anyway, so I hope that you enjoyed the lesson and you had lots of fun, and be ready for class tomorrow. See you there.